Hi, my name is Rodrigo Ramirez and welcome to the Spec Lab. This is the first video in our Data Management 2 module. We'll be exploring the theoretical basis for tidy data, the reasons we want our data to be tidy, and what we can do with data once it is tidy. Raw data is usually messy, and messy data is unusable data. If you try to use messy data, the issues can be as simple as a few values being unintentionally left out or included in your analysis, or as complicated as totally transforming the results of an analysis or visualization, or making the analysis or visualization impossible altogether. To solve this, we turn to tidy data. Tidy data is basically what it sounds like. It's a system of organization where everything has a place, and we will find one and only one thing in that place. When data is tidy, the structure of the data matches the meaning of the data. There are 4 tenets of tidy data sets. Every row is an observation, every column is a variable, every cell contains one value, and every table contains only one type of observation. With these rules, we can be sure that our data structure matches our data set's meaning, and that our data is ready for us to do whatever we want with it. To be clear, tidy data sets need not be devoid of missing or NA values. Missing values are an often unavoidable part of data sets, and we can work with that. Once data is tidied, it can be understood by humans and machines. It's important to remember that data sets are meant to represent certain details about how the world works. With messy data sets, it's hard to extract the meaning that the data set is meant to represent. So the reason we aim to tidy data sets is to ensure that the structure of our data matches the meaning of our data. This is where tidying data comes into play. By organizing everything in a systematic way, functions that we feed the computer can work as intended to interpret data, so long as the structure and meaning of our data match. Once our data is tidy, we can run statistical analyses like t-tests and regressions, and we can create beautiful visualizations to interpret data graphically. But we can't do any of that until we've cleaned up the mess. So that's where we're starting. If you can take messy, raw data and tidy it up, you can create value in any organization you're a part of. Now let's check out some common examples of messy data we may run into and explain how to clean this data up. This is a data frame containing 2 of Barrow and Lee's measures of educational attainment. These data represent the percentage of the population aged 15 to 19 that's received secondary school education, as well as the percentage of the female population that's received secondary school education on the country year level. When data is tidy, every column contains a single variable. But what happens when we have multiple variables in the same column like in this data frame? Well, we can't do much with this. When we have multiple variables represented in a single column, we're unable to actually get a clean look at how the value of either variable is changing over time or is spread over space or anything like that. Even if we wanted to run mathematical analyses or visualizations, we couldn't, because the structure of our variables doesn't match the meaning of our data. We see the same issue when we consider how our years are structured in this data set. Rather than having a single column with the variable titled year, we have multiple columns, each corresponding to a single year in our data set. This may not seem problematic at first, but in reality, this makes our data really hard to work with. We need to gather all of our year values together in order for our data structure to make sense. These data use a country year unit of analysis, meaning that when these data are tidy, each row should represent a single country in a single year, and each column should contain a variable with information about that country year. Each row should be an observation, and each column should be a variable. So let's gather these columns into a single variable titled year using pivot longer, a tool we'll learn more about later in the module. Now our years are all neatly compiled into one column, and we see that our values are compiled in a column to the right of that. So let's move back to the single column which contains 2 variables. To tidy the data, we have to separate these variables and spread them across 2 columns. Let's take a look at how these look when we do that using pivot wider, another tool that we'll pick up later in the module. This is now a fantastic example of a clear and concise data set. We now have a structure that lets us accurately convey the exact meaning of our data set. We start by addressing the elements of our unit of analysis, which country and which year are being measured in a certain observation. We follow this up with the values that map to each observation for either variable we want to work with, the full population or the female population. We've successfully transformed a messy dataset into a clear expression of some details about the world. Now it's time to try it on for yourselves. In the rest of this module, we'll work in RStudio and use the tidyr and dplyr packages to tidy up messy data, to organize data in a way that is easily interpretable for both people and computers. These are the tools that let us take messy real-world data and prepare it for both analysis and visualization. Best of luck.